Here is step 2 of 8 for our chapter 2 ladder review. And in step 2 we have several things that we are looking at, but we're mainly looking at this function up here. And for part A, we're going to just jump in. It says, what is the degree function? We're talking degree of function. We're looking at the highest exponent for x, and so x is the highest exponent here is going to be 3. So my degree is going to be. B says state the maximum of turns of the function, and what we learned was that for some number of turns, that's really just 1 minus the d. So if I take 3 minus 1, that's going to be 2. The maximum number of turns that I can have with this function is. It says describe the end behavior function, and the book talks about it in sort of interesting way. It talks about rising and falling, and so what we're going to say here is that the function will. Thinking about this, some sort of cubic function. If I go back, some sort of cubic function. Cubic functions in general. If I think about the parent function x cubed from left to right is going upwards. It's rising to the right and falling to the left. And because it's negative here, it's going to do the opposite. So this function is going to fall. Function falls on the right, or as it moves to the right, and that is because the coefficient is negative. And in that same manner, we can say the function, I should just say fall up there, the function will rise on the left. And I know that because the degree of my function is odd. Now there is another way to think about this idea of end behavior, one that you might, sort of a definition you might see more so in Algebra 2 or maybe even Calculus, depending on where you're taking that. And so what I'm going to say is, if I look at this function, you can graph using your graphing calculator, and that is a great method to be able to look at what the end behavior of this graph would be. And so what I'm going to do is I'm going to say as x goes to infinity, so positive infinity, so as my function goes to the right, the function f of x is going towards negative infinity, so it's going downward, and that makes sense here where I'm saying the function is going to fall on the right. And likewise, I can say that as x goes to negative infinity, our function is going upward positively. And so that is what we can say about our end behavior. Part D says to calculate the y-intercept. If I want to calculate a y-intercept for any function, I can plug in 0 for x and see what my y is going to be. You can already guess what that's, so that's going to look, but also 0 is equals, and I'll just put in 0 for every x that I have. negative, and then 0 cubed plus 4, 0 squared plus 2 times 0, that's equals 0. So minus 8. Now be really careful here. This question specifically asks you to give the y-intercept, and so we do want to write that as a coordinate point. So we have 0, comma, negative 8. If I plug in 0, I get negative 8. That is my y-intercept. Next piece, letter E, was to find the zeros of the polynomial by factoring. This is a cubic function, and so really the way to go about factoring this is to factor by grouping. And so here's what we're going to do. The very first thing, so I'll just write out this function down here so we have it. So this is our function. And one thing that will make this a lot easier for us, since we have this negative 1 as our leading coefficient here, it would be nice to be able to factor that part out. So what I'm going to do is I'm going to go ahead and say, well, if I take that negative out, if I factor out that negative, then that would leave me with x cubed. And if I take a negative out from positive 4x squared, that would mean that this would have to be negative 4x squared. This would be negative 2x, and this would be positive 8. And then the way that factoring by grouping works is we're going to try and factor these two pieces and these two pieces. And so what I'm going to do is, looking inward here, I'm saying, what do these two terms share? What is the most that I can take out from these two pieces? And I'm going to say I can take out an x squared from both of these. So I still have this negative on the outside of some parentheses, and what I'm going to say is I can take an x squared from both of these, and that would leave me with x minus 4. Now, to be able to do this factoring by grouping, when I factor negative 2x plus 8, I need to pull out something where I'm left with x minus 4. So I need this to look very similar here. What I'm going to do is I'm going to say, well, I think that I can take a negative 2 from negative 2 and 8. I can factor that out. So I take out a negative 2. And on the inside, that'll leave me with x minus 4. And that's exactly what I'm looking for with this factoring by grouping. These two things have to match. And so what that leaves me with is I still have this negative sign on the outside here. These two pieces on the outside, they make up one of our factors. So we'll say x squared minus 2. And then these tell me that I have a factor of x minus 4. And so that is how we would go about factoring this. And so then if I'm going to find the zeros, remember this is really up top here, I should have written originally f of x equals this. So when I get down to here, this is our function in factored form, looks like this. And what I can do, if I want to find zeros or x-intercepts, we can use the zero product rule. And so what I'm going to do is I'm going to set this equal to 0. And the zero rule says I can, if this function equals these factors, there's 0, so I'm going to say x minus 2 equals 0. And x4 equals I'm going to do a little bit of algebra here on the left. I can add two sides. I get squared equals positive 2. I can take the square root on sides, which gives me plus or minus out front. It tells me that x equals or minus the square root 2. So I have two zeros here. On the right, I can add 4 to both sides. gives me x equals 4. So moving down to part F, part says to write the x-intercept using zeros, and so a 0 were both positive square root of 2 and the negative square root of 2, so write those as an x-intercept. I have the square root 2, 0, all in order, so I'll say negative square root of 2, comma, the square root of 2, comma, 0, and for comma, 0. And that is the x-intercepts using our 0 zone. And last but not least, here we have G, and G says state whether the graph touches or crosses the x-axis at each x-intercept and why. And this has to do with this idea of multiplicity. So when I look at my zeros, these zeros all had a multiplicity of 1. I only those happening one time. And so what happens is that all zeros, so all three zeros, cross the axis. And we know they're going to cross the x-axis because the multiplicity is odd. Multiplicity is 1. Is odd. And so, if it were the case that any of my zeros had a multiplicity of an even number, such as 2 or 6, then instead of crossing the axis, we would be just touching the x-axis. So we could have a multiplicity of 1 for all three of our zeros. That would mean that we are crossing x-axis.